Oh my god, it's not that serious. Okay, so you understand that, dude, look at me, not the video. You understand that n times n is n squared, right?
Yeah.
Obviously. So, if we do n minus 1 times, like in parentheses, times n plus 1,
Yeah.
you're going to get n squared minus 1. That works with any number. And if you do n minus 2 times n plus 2, you're going to get n squared minus 4. Because the difference, like the minus 2 and the plus 2, multiplied, the 2 and the 2 multiplied is 4. So it's 4. And before the 1 multiplied is 1. So that's why the difference of the end results are 1 and 4. And if you do n minus 3 times n plus 3,
you get n squared minus 9.
Yeah. So
there's a pattern.
Yeah, there's the pattern. That's the simple version.
Oh, nice. Oh, so
we're
doing next level now.
What you're doing there is just multiplying 1 times 1 and 2 times 2 and 3 times 3.
Mm-hmm.
Those are just squares. But if you don't do squares and you do... See, here's where it gets confusing and you can't use n. If you do, instead of n, I'm going to say a number now. If you do, say, 3 minus 1, in parentheses, times 3 plus 2, so they're not the same number.
Isn't it 3? It's n minus 1. N equals 3.
Equals 3 in this case, but it doesn't work for any number.
Oh.
So 3 times 3 is 9. But if you do 3 minus 1, which is 2, times 3 plus 2, which is 5, you get...
3 squared minus 1. 4 squared minus 1.
You get what? 3 squared plus 1.
Oh, right.
You get 3 squared plus 1. If you do... I don't know how to explain this. If you do 2 times 2, so 2 squared is 4, and then you do 2 minus 1, 1, times 2 plus 2, 4, it's 1 times 4, you also get 4. So the difference is equal. 2 times 2 is 4, and 1 times 4 is also 4.
So in that case,
the difference is equal.
It's the same. The difference
That's because...
No, there's no difference.
Well, yeah, there's no difference.
Yeah.
That's because if you do the differences, I was doing 2 times 2, and then 1, so that's 1 less, and 4, which is 2 more. The 1 times the 2 equals 2, which means 2 is the base, the zero difference between the two, Okay. So the 2 times 2,
so that's
the result of 2 times 2 is the same result as 1 less, 1, and 2 more, 4. It's going to be the same result. So, and if you do any number more than that, for each number it gets 1 higher. So if you do 3 times 3, it's going to be 9, and then you do 1 less, 2, and 2 more, 5, it's 10. That's 1 more, because 1 over 2, over the base.
Mm-hmm.
And that works with any 2 numbers. So in this case we're doing 1 less and 2 more, so we're doing 2 times 2 and then 1 less, 1, and 2 more, 4.
And minus 1 times n plus 2.
Yeah, but the thing is it can't be n in this case because the number changes the results. It's not going to be n squared minus 1 always, or n squared plus 1, because if you're doing 2 times 2 and then you're doing 1 times 4, the result is
Well, the
going to be the
result's
same.
different. You can still say n, but when n equals 2, then
It changes.
then
Yeah.
it's this. When n equals
Yeah.
3, then
Yeah.
it's this.
But it's still but the result changes.
Yeah. So
So instead of doing 1 and 2 as the differences, we're doing 2 times 2, and then we did 1 less 1, and then 2 more 2. You can do 2 and 3 difference. So you do, if you're doing 3 times 3, it's 9, and then you do 2 less 1 times 3 more 6. 1 times 6 is 6, which is 3 less. So we just did 2 and 3 as the differences, right? So 2 times 3 is 6, which would mean that 6 is the base. So if you do 6 times 6, you get 36. And then you do 2 less, 4 times 3 more, 9, 4 times 9 is also 36. And for every number less, or for every number more, it's going to be 1 more, 1 less, or 1 more.
that's crazy.
Yeah, it's pretty interesting. But I just realized that if instead of doing 2 less and 3 more, or 1 less and 2 more, and you switch it and you make the first thing, the thing that you're subtracting, bigger than the thing that you're adding.
Oh, instead of doing n minus
n minus 1, well,
n minus 1 times n plus 2,
plus
you want to
2,
switch it around to n minus 2
or
times
just
n plus 1, for example.
Yeah.
And then what happens?
And this doesn't only work with 1 and 2 and 2 and 3. You can do 1 and 3, I'm pretty sure, too. If you do 1 and 3, 1 times 3 is 3. So if you do 3 times 3, that's 9. And then you do 1 less 2 times 3 more, 6. Never mind, it doesn't work. I'm confused.
Huh.
It's weird.
So what happens when you do it that way? Then you get n. Then it's n squared plus something
I don't know what happens when you do it that way.
instead of n squared minus.
Point is, I just realized
something.
that if you do the first number, the number that you're subtracting, bigger than the number you're adding. So instead of doing 1 less, like we're doing the 2 times 2, and then we're doing 1 less 1 and 2 more 2.
Say that again.
We were doing 1 less and 2 more, right?
Oh.
Than the number.
Oh yeah.
And then we did 2 less and 3 more, right? We tried that one out too.
N minus 1 times n plus 2, and then we did n minus 2 times n plus 3, right?
Yeah. Well, if we switch them around, or not even switch them, if we just make the one that we're subtracting, bigger than the one that we're adding.
N
So if we
minus
do,
3
so
times
if we do,
n plus 2, for example.
Yeah.
Oh,
So if we
right.
do 3.
So instead of let's do an example. Yeah, instead of 3.
Yeah, 3 times, instead of 3 times 3, 9, and 1 less and 2 more, we would do 2 less and 1 more, for example.
Right.
So if we did 1 less and 2 more, we would get 2 times 5, which was 1 more than 9.
N squared plus 1.
Yeah.
Right.
Well, in this case, but
right, because the base.
Because it's 3, because the base is 2.
Right.
But if we did, instead of 1 less and 2 more, we did 2 more and 1 less, we would get 3 times 3, 9, and then 2 more, 5 times 1 less. No, 2 less. 2 less, 1 times 1 more, 4. Yeah, I'm confused.
You get 4.
You get 4.
That doesn't make sense to subtract more than you add. Well, let's do it with the bigger one. Let's do 5 times 5.
25.
And then 4 times
7.
4 times 7, 28. So n
It's
squared plus 3.
more. Yeah, it's
And
3
do it the
more
other way.
because
Instead of
5
5,
is 3 more than 2.
instead of 5 times 5, you get 3 times 6, right? Minus 2 and then plus 1. 3 times 6,
Yeah,
18, which is n squared minus 7. What was the other one? Was with 3 it was n squared minus 5. So with 4 is it going to be n squared minus 6? 4 you get
But why?
4 is how do you do that again?
4 times 4 is 16, and then 2 less 2 times 1 more 5. 2 times 5 is 10, which is 6 less than 16.
So it is 6.
So it is 6. But
So
why?
it's n
Why?
squared
Why?
minus
What?
5, n squared minus 6, n squared minus 7. And then, so if you do it with 6, instead of 36, you should get 28. It's going to be 4 times 7, right? Instead of 6 times 6.
Yeah, but why?
Well, you have to do a diagram, because if you make a chart with like a grid, like all these
that's what I was
multiplications are like
saying, but
grids.
I don't know how to do that. I don't know how to do that.
We can do that tomorrow. Make a
Yes,
diagram.
that
of it.
was what I was gonna do tomorrow.
Oh, nice. All right, well, let's do that tomorrow. All right, guys, thanks for watching. It's been great. Stay tuned. Next time, we're going to talk about Heisenberg's uncertainty principle, or if that doesn't work out, we'll do a recipe for banana bread. Bye.
Bye.